Hey there, hey there, and welcome to Into the Terminal, episode 40. Today we're going to be talking about deploying a database. Scott's laughing at me because I forgot to mute my monitoring tab, so I'd heard myself speaking. Anyway, down to business. So today we are going to work with MariaDB, and as often as a systems administrator, we have to install a database and get it set up for database administrators to configure. So first, we're going to install the MariaDB package alongside the MariaDB server package. We'll do that with our DNF install command. We'll go out, check our repositories, pull down the latest versions. And it is good to note that later on in the episode, we are running Red Hat Enterprise Linux 8.6 today. We'll be talking about application modules later in the episode, so stay tuned for that. Once the database is installed, we need to do a systemctl enable tac now on the MariaDB database service. The -- now does basically a systemctl enable and a systemctl start on the service, so we can combine those two commands into one. Next off, let's double check and make sure that our service is up and running. There's no conflicting processes or anything, so green means good. Moving forward, we may have a web server or something that is running on a remote system or another device. So let's go ahead and open up the firewalls, the appropriate firewall ports, and we'll do that with firewall-cmd command. And in fact, MySQL is already a defined service, so all we have to do is an add service on MySQL, and we'll want to make that permanent. And then let's reload our configuration. So now our database service would actually be available from a remote system. So you notice on this box we only have the MySQL service allowed through the firewall. So what this actually does is there's a configuration file within user lib firewall-d services and MySQL. And so this will actually open up port 3306 through the firewall. And this is one of many pre-configured services that come built into the firewall utility. Finally, let's go ahead and connect to our MySQL database service using the MySQL utility. We'll use a -u to connect as root, and by default, that password is not set.
We don't know, but it turns out that root doesn't need password by default.
And with that, we have a running database and a running database service. A lot of times as a systems administrator, this is as far as you'll need to go. But if you stay tuned for the second half of the episode, we're actually going to talk about how to better tune your operating system for database workloads. We'll talk about creating your first user and first database. I've had to go and create databases that database administrators have had to log into, so we'll cover that. And of course, because this is a live event, we'll also take your questions. Welcome to Into the Terminal, episode 40. I cannot believe that we're already up to 40 episodes. But today we've got our second episode in our workloads story arc. Last week, if you missed, we talked about Nginx and HTTPD. And today we're talking about databases. So I'm Eric, the IT guy Hendricks, and Mr. Scott McBrien is joining me today. How you doing, buddy?
Good. How's it going, Eric?
Well, other than forgetting to mute I always keep the live stream running in a separate tab just to make sure that the stream is actually working. I forgot to mute it, so as I went to go do my intro, all of a sudden I started hearing the music and was confused for a moment. So there's never a dull moment when you're hanging out with me and my crazy brain. All right, so let's dive in. We teased this before the transition. Let's talk about app streams, and then we'll talk about tuning database workloads on our system.
So I think the first thing is that MariaDB is not the only database that ships with Red Hat Enterprise Linux. We actually ship 3, actually more than 3, because there's some like NoSQL ones too, right? Let's take a quick look.
Oh yeah, that's
So we chose to use MariaDB today because it is the open source project that was spawned off of MySQL. MySQL is also shipped with RHEL. MySQL 8.0.26, I think, is the most current one that we ship. And then just scrolling up through the list here, there's Redis, yay. Postgres, got a couple versions of MariaDB. Here's the one that we installed as part of the first part of the episode, 10.3, which is the default version that was selected because I didn't specify a version. And I think that's it. That's it.
Oh, is that all?
Is that exactly?
And for that matter, we actually partner with several different organizations. Like you can get licenses for Oracle RAC databases or Microsoft SQL Server that runs on Red Hat Enterprise Linux. So these are just the list we're looking at today are just ones that we support within the Red Hat repository ecosystem. So plenty of databases run on Red Hat Enterprise Linux, but a lot of times if you've got a small web app or if you've got just a small database need, usually MariaDB is one of the easiest ways to go. And in fact, in the show notes, we'll link to an episode that we did that'll go in deeper on app streams. I should have grabbed that ahead of time, but we did a whole episode on application streams and how to interact with those. But for now, we just took the default and enabled the application stream for MariaDB. So let's talk tuning. While Red Hat Enterprise Linux is designed to be very, very vanilla right out of the box, so it can run a multitude of different workloads, we can actually go in and there's knowledge base articles out on the customer portal that will kind of guide you through some of the best practices, things that we've developed alongside of the open source community around Maria to improve operation, to improve performance of your operating system while running a database. And the first one, Scott, that we want to talk about is swappiness.
Yeah, so before we actually get into there, I should have a brief disclaimer, right? So the people that maintain the distribution are really smart people. And they make choices based off of a large swath of use cases. So when we start looking at things like tunable settings, what we're talking about doing is making our machine better able to perform a certain type of task, but that's going to make it worse able to perform other types of tasks potentially. So as we start talking about these tunable settings, don't just take these and like apply them to everything. These are specifically tunables that we're updating to make our machine better for database-based workloads, and that may make them worse for things like web server workloads, right? So you have to be really tactical when you're applying these changes to make sure that you're optimizing your machine for your workload. All right, so Eric, you said the first one was swappiness.
Yeah.
So for all the folks at home, the tunables that we're about to talk about first are all kernel tunables, which are stored in proc sys somewhere. And swappiness is in the virtual memory directory. And it is currently set to 30. Swappiness is a value that runs between 0 and 100, and it sets your kernel's affinity for using swap space. There is no way to turn off swap space but you can make your kernel less likely to use it. And so by changing this to a recommended value for databases of 10, we have made our kernel less likely to utilize swap space. So that means that it will store things in memory and not swap them out, even though they may be private data or some other things that are swap eligible, until certain memory things happen, and then it will utilize the swap space as required.
And this was a new one for me. How about vm.dirty_background_ratio?
Yeah, so we actually have like a set of 4 virtual memory tunables that affect dirty pages. So let me show you the 4, and then we could talk about what they do. So they're all in the virtual memory tunables for the kernel. All right, the first one is dirty background ratio. So this is when your memory is 10% full of dirty pages, which is cached page writes, then we will start synchronizing those out in the background on the machine. So the kernel will start up a thread or more and actually start performing file writes out of this group of dirty pages that is stored in the file cache. The next one is just called dirty ratio. So this says that 30% of our memory, system memory, can be consumed with page cache. If we reach above 30% of our memory, the kernel will have to stop what it's doing and start synchronizing out those buffered writes to the disk, because we've got too much file writes and file updates stored in RAM. We need to actually persist them to disk. The next one is expire CentOS. So this is a weird measurable of time. So CentOS or centoseconds is 1/100th of a second. All right, so we're set to 3,000 centoseconds, which really is 30 seconds. And what that says is that when a file write is stored as a dirty page in file cache, it can persist there for up to 30 seconds, and then we need to be looking at writing it out to the disk. All right, and then the other one is write back CentOS. So this is another one where it's in centoseconds, right? So this is really 5 seconds. And once the dirty page has exceeded this setting, and I can't remember exactly what write back is, I'll have to look it up while we're talking about maybe doing some database operations. But after 5 seconds, it'll cause this page to be have something done to it. All right, so what we're going to do is we're going to take these 4 page cache settings, and we're going to make some changes to them. All right, so we're going to take dirty background ratio from 10% to 3%. We're going to take dirty ratio from 30% to 40%. We're going to take dirty pages from expiring from the page cache from 30 seconds to 5 seconds. And we're going to update this write back CentOS to take its activity from let's see that. I messed it up. Hold on.
One of the reasons why these kernel changes are so effective is databases pretty much exist completely in memory, depending on the type and size of database and the type of system that it's running on. So what we're doing is we're basically making it easier for the database to pull in the data that it needs into memory, so it's more readily accessible. Because when you're talking about memory versus disk writes, memory is a much, much cheaper operation in terms of time and resources than a disk write.
Well, and I think you said disk write, but I think you meant disk read.
Or yeah, disk read.
Yeah, and so what we're doing here is we're changing our preferences for disk writes, right? So in the database operations or workload, if we have to go out to the disk to read a piece of memory in or to read a piece of data in, but we can't do that because there's a bunch of queued up file writes in front of that read request. That will degrade our database performance, which we have some app out there waiting on to get that piece of data that we're looking up out of the disk for our database. So what we're doing with these changes to the writes is we've made it so that we start synchronizing writes out faster. So when dirty pages, the file writes that need to be written out to disk, are 3% of our memory, that's when we should start actually trying to write them out with a background task. We'll allow dirty pages to occupy 40% of our system RAM from 30%, right? So if for some reason there's like a bunch of file writes that happen, we will allow our machine to hold more of them in memory than we were before. And then the write backs, we took the expiration on writes and we reduced it significantly. So instead of 30 seconds, it's 5 seconds. Instead of 5 seconds, it's 1 second. So that what we're trying to do is instead of storing all of this in memory and then freaking out and realizing that we have to write a bunch of stuff and like pausing everything that's happening on the machine to do those writes, we can start earlier and do smaller amounts of writes to impact those reads much less. All right, and along the same vein, there are some other tunables that you can set for databases as well. So there's another article that we've got that talks about Oracle tuning for the Oracle database. And in there, they reference the semaphore value as well as shared memory total for the system, as well as individual shared memory size allocations. And let me show you the content of those currently. So these are the values for semaphores that we have on the system. And that's for all shared memory and the max share, or the maximum size of individual shared memory content. All right, so if you go out to the Access article that Eric pasted, you'll see a couple things. One is our default semaphore sizes on this machine are much larger than the ones referenced in the article. The ones referenced in the article are a minimum value. So the fact that we have more of them is good, right? We don't need to mess with that. And then for Schmal and Schmax, I've seen sometimes where some articles that you'll find out on the internet have values that they tell you to plug in here. Don't do it. Schmal and Schmax are a mathematically derived value based off of the amount of RAM on the machine. So if you just take like random values on the internet and shove it in there, well, does your system memory that you have available match the person whose article you're copying and pasting from? Highly unlikely. So the article that Eric linked for Oracle tuning, it actually gives you the equations that you need in order to appropriately calculate what these values should be. But like, that's a lot of memory for smallish Macs on this box, and I think this machine only has like 4 gig available. So like, I doubt that we would need to make much changes here. The last tunable that I want to cover is disk IO, and it's related back to what we were talking about earlier, where reads are really important to database workloads because you need to be to retrieve that data to provide it back to some application or user that's sitting out there waiting for it. So we want to choose our disk elevator carefully. So in sysblock, my block device is SDA. I'm interested in the IOQ and the scheduler. So there are 4 schedulers that come with Red Hat Enterprise Linux 8, and I believe the same 4 are there for 9. So none means there's no disk scheduler. I'll talk about why that is in a second. MQ deadline, if you're looking at an older RHEL box, like a RHEL 7, this was just called deadline. And essentially it gives you finite times that both read operations and write operations have to be executed in. And then Kyber and BFQ, those are, or Kyber is a specific latency time that you won't let read or write operations exceed. And BFQ is a type of fair queuing so that it doesn't give overly preferential treatment to reads or writes. Right? Deadline gives preferential treatment to reads with the default configuration. So BFQ would be like equal treatment for both reads and writes. All right, so for your database workload, depending on whether your machine is a virtual machine or a physical machine, we'll choose which of these schedulers is right for you. So if you are a physical box, MQ deadline is probably more right for you. MQ deadline lets you set the preference for read operations. By default, it actually prefers read operations to give those database lookups off of disk the priority that they need in order to get that application workload snappy and returning quickly. However, this is a virtual machine that we're looking at. And so we have appropriately selected none. On your RHEL 7 or earlier boxes, this is probably a scheduler called no op, which means no operations are required. And the reason that's important is because this is a VM sitting on top of a hypervisor. And that hypervisor has its own method of managing IO requests. So if we spend a whole bunch of time ordering what write requests and read requests we need, and then we send them to the hypervisor layer is going to reorder all of those based off of its settings. So for a virtual machine, we recommend none, or on earlier versions of RHEL, no op, because then it'll just send the operations as they come, and we're relying on the hypervisor layer to do the actual coordination of which disk preferences should be made. That was a really long description of why we should make these changes. One last thing, Eric, when we were going through and making changes to our proc tunables, so like copying this here, I just put values directly into this file in memory, and it's stored in memory, which means if we reboot the machine, it would be lost. So if we want those changes to be persistent, we'd have to store them in a configuration file. And the way that we persist changes to, or I should say one way, we can persist changes to the procsys directory is this file at sysctl.conf. So we can
use extreme caution when working with a sysctl file. I've managed to break systems many a time as a sysadmin by fat fingering something in this file. I mean,
Well, you want to
well,
make sure
no,
that
I've never messed anything up.
there are some tunables in Proxys that if you put the wrong thing in there, it can make your system really unhappy. Like there's a file in there called panic that will cause your kernel to panic. So like you don't want to change that one because it'll cause your kernel to panic. All right. So now I've put my tunables in there. I might want to put some comments around them to like let other people know why I tuned these things this way. But that's how you would make them permanent. The other, and I think more better way to make them permanent would be to use a tuned profile. And Eric, we were just talking about that. When's our show on tuned?
So we've got it on the roadmap. Right now, I think it may be December, but based on this conversation, we may pull that episode up. But stay tuned. All the more reason to like and subscribe so you get notifications anytime that our content comes out. One other disclaimer, real quick. We included an access.redhat link, and you will notice that that is behind a, for lack of a better term, a paywall. However, if you have an access.redhat account along with the developer for individual subscription, you can actually get access to that to that content without being tied into a paid subscription. So if you have a developer for individual subscription, you can get into the knowledge base and be able to read that tuning article. It is very in depth. But it's well documented, well explained, so definitely worth a read if you spend a lot of time managing databases. We got a couple of questions in chat, and the first one is from Shantanu, and says, does RHEL have some sort of interactive QA tool or script that asks questions and emits out specific values? Basically a way to, basically a wizard to help tune your system based on workload?
So no, because workloads are very specific, right? Like when we're making tunable changes, we're making things worse for other kind of workloads. So we don't want to assume what you're doing with your machine and just like make blind choices. Plus other things like the semaphore values or shared memory, like that's tied to your specific hardware. So we wouldn't be able to just make guesses as to what the correct values should be for those. So we purposefully don't make a turnkey tunable profile-y thing because there's a lot of choices that you might want to make that you wouldn't know or that we wouldn't know for you. The other thing that you might try is tuned. We talked about that as a method of making your tuning changes permanent, but we do ship several tuned profiles. So if I use the tuned ADM command and look at the active tuned profile, this machine is running in a cloud provider. And so it is using the active profile virtual guest. And that's one of the reasons why it has the none disk elevator selected, because the tuned profile for virtual guest says, don't bother doing IO changes to the queued up IO because somebody else is going to reorder it for you anyway. There are other tuned profiles as well. So these are the list of them. You can also get some more if you install the right RPM. So for example, if you install some MySQL packages from RHEL, you actually get a MySQL server tuned profile that has some changes for that workload. So occasionally you'll have one that's set up for a specific application where we've worked with the ecosystem partner for just determining what values we can set without being overly prescriptive. So some things of interest here, things like throughput performance. So let me highlight that so you can find it. So throughput performance is what a lot of our other performance-based profiles are based on. Essentially, like turns off power saving and does some other settings to make sure that you get the most performance out of your system as you can. Virtual host and virtual guest, you see down there at the bottom. That's things that you should do if you're a guest VM on a hypervisor, or if you're actually a hypervisor hosting VMs. Here are some changes that we could make. And then one other one that I'll just highlight real quick is the power save. So like on a laptop, power save might be interesting because it will, when your system's not very busy, turn down the frequency of your CPU and make that battery of your laptop last longer. Or if you were in a place where you're concerned with power draw, you could turn on the power save tuned to make your system sip at that power coming into it rather than gulp it down as hard as possible in order to output as much compute as possible. The other things that might be interesting, so VirtWhat and VirtWho are two applications that will tell you what virtualization you're using, or VirtWho tells you what your virtualization provider is, so you can see whether you're like a RHEL KVM or a VMware guest or something like that. Yeah, so those are some tools. You can also look at other system data like EMID code, which gives you a bunch of BIOS data. But you can see here in my BIOS that this machine's BIOS is provided by Google because it's a GCP provided machine. If you looked at an Amazon AMI that's running, it probably says Amazon in these fields. VMware says VMware in these fields. So that's another place. And in fact, that's what Tuned looks at to try and pick like if it's a virtual workload or not. So that's another place where you can go to try and find some information about what your system is actually running on. We have deviated a lot from database.
And with that, that is a 2-minute look at our upcoming episode on Tuned. So we're actually at the bottom of the hour, so thank you all for joining us live. But one thing that I will share is if you check the show notes here in a couple of hours, we add in list of commands we've interacted with. We add in additional resources, links that pop up in the show, so you can just copy and paste those. And one that I'm really excited to share with you is there's a website called devhints.io. This pops up frequently when I'm searching on the internet for different things, and they have a MySQL cheat sheet. So we didn't actually get into the MySQL tool beyond just verifying that we could log in. So if you need to go create a user, create a database, and assign permissions to that user for the database, all that is out there. It's formatted really nicely. So check out devhints.io. We'll include the link there in the show notes. But other than that, that is an awesome look at installing, configuring, and tuning your system for databases. So here, a week from today, join us for episode 41, where we'll be talking about the NFS service. That's Network File System or Network File Server, depending on the application. But other than that, Scott, thank you so much for joining me. It's always a good episode of Into the Terminal when I learn something. And I help write the episode guides, and I still learn stuff. So it's always a good time. Always appreciate it. Those of you that joined us live, thank you so much. Those of you that are catching us after the fact, please put your questions in the comments. We check those pretty much once a day at this point. We've gotten a lot of good engagement, so put your questions in the comments. If you have ideas for future episodes, put that there. Otherwise, like and share with a friend. We'd love to grow our live audience and have you all hang out with us on Friday afternoon. But other than that, I've been Eric the IT Guy Hendricks, and my co-host is Scott McBrien. And on behalf of the entire Red Hat Enterprise Linux team, thank you all so much for joining Into the Terminal, and we'll see you next Friday.